Thanks so much, Frank, for this nice introduction. So I suppose today I'm going to just give you an overview on the measuring and the challenges of measuring carbon sequestration at different scales. That doesn't work, though, but I can watch in there. Okay, so just a little bit of an introduction. Soil carbon plays a crucial role mitigating climate change, enhancing soil fertility, and supporting the overall ecosystem health. We know already how the carbon is distributed in our soil. So more than the double of the carbon that is actually in the atmosphere is stored in the first meter of soil. This makes the soil the largest terrestrial carbon pool, highlighting his role and his importance for the global carbon cycling. In the Irish scenario, soil is a net source of carbon loss. Peat soils are acting as a source, accounting for 3.9 megatons of CO2 equivalents per year, while mineral soils are acting as a sink with 1.4 megatons of CO2 equivalents per year. Now, the LULUCF, land use change and forestry inventory, is highly uncertain. And the national inventory report went through 3 changes in the last 3 years. So we have targets. The LULUCF targets account for 0.626 megatons of CO2 equivalents per year. And the agricultural emission targets set reduction of CO2 emission in the atmosphere of about 25%, bringing us to 17.25 megatons of CO2 equivalent per year. So these are really difficult targets to reach in the future. Researchers in Teagasc, though, have been looking after a framework for climate-smart land management, focusing on carbon and how to manage carbon to improve the sequestration, which is based on 3, let's say, key activities. Maintaining carbon stocks is one of them. We have been asking ourselves, where is the carbon stored in Ireland? And the answer is the majority of our carbon is stored in our peat soils. More than 53% of the carbon stock that we have in Ireland is accounted into peats. So identify those hotspots in organic soils and incentivize their maintenance is absolutely key. Prevent new emissions from emission-sensitive soils, certainly avoiding drainage on organic soils, which we know drained peat are high emitters, but also carefully looking after land use change. So, for example, moving from a grassland to an arable situation in certain soil types specifically, it can reduce the carbon stock over the years. And enhance sequestration, identifying new areas for afforestation, planting new hedgerows, but also improving our permanent grassland management, because grassland represent over 93% of our landscape in Ireland, so it's extremely important to keep the balance of this function right. And of course, the research has to look after organic inputs and new amendments to increase carbon sequestration in the soil over the years. But how can we manage agricultural soil to optimize carbon? So just a brief introduction on the carbon cycle. Everything starts with the photosynthesis. The plant uptakes CO2 and uses to grow its own biomass. But at the same time, you have different inputs or carbon inputs that end up into the soil. So, for example, your added organic matter, plant residues, root exudates, and animal excreta. And the turnover, there is no sharp boundaries in the turnover of each one of them. So the important thing is that the turnover rate and the residence time of all these sources in the soil is extremely different. Now, the plant respires CO2 back into the atmosphere, but also the microbes and fungi respire CO2 in their activity of decomposing organic matter. And each one of these compartments contribute differently to the overall CO2 emissions. So research has to step forward to see how to account for these compartments as well. The animal has an important role. There is a certain removal of carbon through silage and grazing, certainly, but also the animal emits CO2 in the atmosphere through enteric fermentation. And then you also have some removals from this system with the leached carbon in the deeper layers of soil. Now, it's important to know that in general, this system is in balance. So if you don't apply any major disturbance to the system, the actual system is in equilibrium. But in general, the carbon that is left over, which we refer to it as carbon sequestered, is the carbon that is actually coming from this complex cycle of life in decay in the soil, and is the carbon that is removed from the atmosphere and stored in organic stocks. And in general, the typical carbon balance for an improved Irish grassland goes between 0.1 to 1.1 tons of carbon per hectare. That is equal to 0.4 to 4 tons of CO2 per hectare per year. Now, the majority of the carbon that is applied to the soil is released back in the atmosphere at some point in the near future. So the carbon that really stays out of the atmosphere over a longer period of time is the one that has the climate benefit. Now, it's very difficult to measure carbon. It's a very small quantity, and it takes a long time to build up. So imagine if we are a farmer and we are starting from this baseline of carbon stock, and we want to improve our management, so we just apply a land use change. We slowly start building up carbon over the years. And this can be at the rate that I was saying before, 0.1 to 1.1 tons of carbon per hectare per year. So you can imagine it's very slow to reach to this point. So from a cropland to a grassland, so if you have a land use change, as you can see from this graph, to reach 100 tons of carbon per hectare, you might need more than 100 years. However, if you do something wrong, so if you change your management, if you change back your land use, for example, you can go back to the square one very easily. So in this case, for example, moving from grassland to cropland, in less than 20 years, you are able to actually lose carbon, over 40 tons of carbon. So carbon sequester is considered reversible, and this is the main message that and very easily. Now, it's not just the quantity of carbon, but also the type of carbon that we have in the soil. The biochemically protected carbon is the more stable one, the one that has higher persistence in the soil, is the one that is not subjected to the breakdown of microorganisms. So it can stay there for hundreds of years or even thousands of years. Then we have this physically protected carbon, which is the carbon that is intimately in touch with the physical structure of the soil. So it's bounded in the silt and clay particles or within micro aggregates. And this is very stable as well. And then you have the unprotected carbon, the labile carbon, that has a very low persistence, and it can go back into the atmosphere in a puff of smoke. There is a bit of confusion between carbon stock and carbon sequestration. Soil carbon stock represented the total amount of carbon that is stored in a specific area, while carbon sequestration refers to the net change in soil carbon stock over time. So you need more than one measurement to assess carbon sequestration. If the CO2 uptake is higher than the CO2 that is released into the atmosphere, your system is acting as a carbon sink. On the other hand, if the CO2 uptake is lower than the CO2 that is released, your system is acting as a source. But are we increasing or decreasing our carbon stocks? Now, in reality, a lot of presentations later in the morning will show the up-to-date results on this. What I wanted to bring to your attention now today is what are the challenges measuring carbon stocks and sequestration potential. Certainly, soil type has an influence. Not all the soils have the same capacity to sequester carbon. They can store different amounts of carbon, affecting their ability to act as carbon sink or source. A sandy soil, for example, has a higher CO2 uptake, but also has a high CO2 loss, so the carbon sequestration potential is quite low. On the other hand, a clay soil has a similar CO2 uptake, but the carbon the CO2 loss is much lower because the carbon tends to be bonded into the clay particles. So the clay protects, in reality, the carbon and keeps all the carbon in the deeper layer of soil. So the carbon sequestration potential in this case is higher than for a sandy soil. And then you have the peat soils with the very peculiar situation with the low CO2 uptake, but also low CO2 loss in natural conditions. So the soil organic carbon can build up in this natural condition. So you have a very high carbon sequestration potential. And I suppose later Matt Saunders is going to talk about this a little bit more in deep. So each soil type has a different capacity for carbon sequestration, but once this capacity is reached, any additional carbon can be lost. So it's important to say that it's not just an infinite container. So we can reach a capacity, over that we can't add carbon anymore. Researchers in the past have been looking at deep carbon, and in particular a paper published by Simo et al. In 2019 suggested that in Ireland we are storing quite a lot of carbon below 30 centimeters, which is accounted up to 40 tons per hectare. More recent results with the SignPost program have been looking at these carbon stocks below 30 centimeters, so below the suggested depth of IPCC. And what we found was that the carbon stock is ranging between 18% to 30% of the overall carbon stocks in the profile. So it's a quite high amount of carbon that we have below 30 centimeters. And this change depends on the soil type. But we knew somehow already that the soil type had an influence. And this is a graph that I've taken from a paper published a few years ago in Teagasc, where we found that a larger proportion of carbon was associated within microaggregates and silt and clay fractions, so in specific soil types deeper than 30 centimeters. So we know already that some soil types, especially the ones that are rich in clay, have a higher potential to sequester carbon in depth. And this is something that we have to take into consideration. Research has also looking into more standardized approach, more efficient methodologies to make measurements more accurate and comparable for carbon stocks. And of course, as I said before, we are looking after a below depth of the IPCC depth, suggested depth. Now, it's complicated to measure carbon stocks. So in general, I'm not going to go through this equation now, but carbon stock is not just one measure. It's a combination of measurement, and in particular, it combines the measures of soil organic carbon content that we have in the lab, and it's a widely recognized methodology, together with the measure of soil bulk density. Now, soil bulk density is not an easy measure to take. It can be time-consuming, it can be really costly, but as well, it can be very inaccurate in to take a sample, a representative sample in the field. And as you can imagine, if there is an inaccuracy in the measure of the bulk density, you're going to have inaccuracy in the measure of the total carbon stocks. In particular, inaccuracy in bulk density measures are related to the increase in the sample of the stone content. So with the higher stone content leading to a higher inaccuracy. So adjust for rock fragments is absolutely key. And this is a paper that we have been published recently, where we have been looking at different calculations methods found in the literature to account for carbon stocks in general. So what we found, we compared different methodologies with the gold standard methodologies, which account for rock fragments as well as for a precise volume in the core. And we found that those methods used in the past could have been leading to inaccuracy of carbon or carbon stock, and in particular overestimation up to 300%. So the long and the short of it is just we need to have a coherent measure to assess carbon stocks over the years and across scales. Now, our research mission is still understanding what are the drivers of soil organic carbon sequestration. Is it the soil type, so the intrinsic characteristic of the soil, the climatic condition, the land use, or the management, or a combination of all of them? So in general, we are starting to answering this question. So for us as researchers, so what we want to bring ourselves forward is, are we able to develop a baseline for carbon stock at national level? Can we develop sequestration factors ultimately based on farming scenarios in Ireland? And this is what we have been looking for. Now, this is a three-pronged approach for measuring, reporting, and verification platform. Stuart Green is going to talk about it a little bit more in deep later, just to say what we are picturing ourselves doing in the future, what we are doing now, but what we will be doing in the future as well. We have to measure soil carbon and weight with long term carbon measurements. So this is absolutely important because, as I said, carbon sequestration is not just one measure. We have to go back, especially in deep. We have to measure fluxes. So we're using eddy covariance towers and to have a better idea of the short-term carbon balance and measurements. We want to use existing data that we have, especially metadata on climate, soil, land use, and activity data, together with new data that we will be developing. What we want is to bring all this in a modeling exercise, a soil modeling, so that we can account for carbon change over time, and we can input these values into the new, the national inventory. The SignPost farm is just briefly an overview. We have been, so I'm leading the soil carbon campaign, the deep sampling campaign for SignPost. Rachel Murphy is going to talk about preliminary results later on. We have been looking at spatial and activity data together with landscape distribution patterns. And of course, we have been measuring carbon in the topsoil as well as in in the subsoil. This is one piece of information that will go in our roadmap for carbon accounting. And Rachel is going to talk about preliminary results for NASCO as well, the National Soil Carbon Observatory, with 28 ecovariance towers located in different land uses, managements, and soil types. This is how the data from the towers look like. So we are able to measure the uptake and the release of carbon in different scenarios in Ireland, and link this information to the management that is actually happening in farm. So it's quite impressive when we put all these sites together, because we are covering the whole island. Soil carbon and ecovariance data will be used for tier 2, 3 model development, and these models can quantify management impacts on soil carbon and long-term climate impacts. So I suppose this is the roadmap for us into carbon sequestration. So soil measurement with SignPost, flux measurements with NASCO, modeling, so that we can finally get the carbon counted. And then some take-home messages from here. Certainly the inventory is still uncertain. Soil type, and I would push a little bit into clay content, is actually setting the potential size of the sink. Land use and management can help to switch to higher or lower factors rate of carbon sequestration, and soil sampling and carbon calculation methods are absolutely important. So, but ultimately what we want is to refine the national inventory for carbon emission from land use and management, reaching the tier 2, 3 approach, combining modeling together with soil sampling and ecovariance measures. And thanks.